Sir, momentum is a product of the mass of some other velocity, sir.
Okay.
Sir, may I go type it?
All right, hold on. Stick up in there. Don't try and overdo it now. Take your time. Take your time. Take your time. Don't overdo it now. All right, don't overdo it. Stick up in there. Don't try and overdo it now. Take your time. All right, listen. All right. All right, Caris. Caris is there. And sure, I missed out all that. All right, Tiffany.
Yes, sir.
Go over what you just said slowly. What your first couple things you say?
Sir, but I say momentum is the product of the mass
Right.
and velocity of an object.
All right. So, all right, good. When we find out the product of two things, what do we do to them? What sign we use to show product? The product.
Sir, repeat, sir.
What sign do we use to show product?
Sir, multiply, sir.
Very good. That's it. So the product of mass and velocity of an object. All right. So basically, that is what we'll accept. But then this question or this topic is concerned about linear momentum. Okay. So linear momentum. So let's see now. What does the word linear mean?
Sir, can you repeat, please?
What does the word linear mean?
Sir, linear have to deal with straight line.
Okay.
Something like that.
Linear means straight line. Very good. So linear means straight line. All right. So basically straight line. And so basically what we're going to say here then, linear momentum. So when you combine that together, right, we get something like this. All right. As the so it's basically the product of mass and velocity of an object in a straight line. All right. So all right. So that's our definition for momentum. All right. Now again, I shouldn't even be teaching this. This is CXE thing, but this is showing me that you guys, I don't know what happened in the exam. Some of them say you pass, but let's see how that go. Linear momentum is defined as the product of mass and velocity of an object in a straight line. All right. Now, in terms of a formula, right, we'll say something like we'll write this mathematically. Okay. And in some textbooks they'll use the symbol P for some reason to represent momentum. So it's that's the formula here. All right, so that's momentum there. All right, now so this should be straightforward. Let's go back to the syllabus here. Them say explain linear momentum. All right, something that we should explain. All right, now. All right, let's hold that. Yeah, let's just get some questions here. Oh, wrong thing. Okay. Right, them say your principle of conservation. So conservation is how far we should go with this topic. Apply the principle of momentum here to deal with collisions and elastic and inelastic collisions. All right, I know the idea is that you guys should know this. All right, here's two sides of momentum then. So let's look at it from both sides then. All right, now momentum. Let's go back to this. All right, so momentum is actually a result of Newton's second law. So let's go. That's where it was first used. So let's go back to Newton's second law. All right, it didn't say this version here. It actually tells you about force and acceleration, but there's another way we could state Newton's second law. So let's get some space here. All right, so momentum. All right, so momentum is derived Newton's second law. All right, now think of it this way. The version of Newton's second law that we're supposed to know, which states says that the rate, it states that the rate of change of momentum is, all right, is proportional to the force acting, and it's right force so that we understand this. The force acting, all right, on an object. So again, this is another way we can state Newton's law. Right. This is painful. Wait something, you know, man. I'm supposed to do that. All right, let me group them together. And I seen the text. Why is the text to them? All right, supposed to insert. All right. All right. So this part is the important part, guys. This is the. So that's Newton's second law. All right, everybody seen that?
Yes, sir.
Yes.
Yes, sir.
All right. So remember that for the second law, there are two ways that you can state it, and they are saying the same thing. All right. They're actually saying the same thing. All right. Now, let's get back into this definition now. Momentum is actually equal the change, and notice that the rate of change. So when modify this, because this is a formula that we will end up using. Let's get a new slide here. And so we're going to basically say that rate of change of momentum is equal to force. All right. Now you're going to end up with something like this. In terms of a formula, rate of change of momentum is the same thing as momentum over time. So it's momentum over time that is equal to force. In fact, change in momentum over time is equal to force. All right. And another way we can write this now, you'll see it in books like this. All right. It's going to be written. Remember that many books use P as a symbol for momentum. And so basically, change in momentum, change, we use triangle to mean change. All right. Momentum is P. And then, of course, time is T. And then now for force, what letter would you use to represent force?
F.
F.
Is it capital or common?
Capital.
So definitely. So you end up with this formula here. All right. And so that is the change in momentum. So what we end up with is a formula that says this then. Delta P and momentum is a vector over T is equal to F. That's our formula. All right. So there are two ways that we can find momentum. All right. In one case, we don't have to know the force. And in the other case, we have to know the force. So the two formula for momentum should be the first one that you say is mass times velocity. All right. And when you use this one, let me just put a note beside it. This one ignores it ignores the force acting on the object. All right, so that is why this formula is used when you're ignoring the force that acts on an object. All right, but when the force now is responsible and then it is of interest, then we use the formula with force in it. So let's take a look at some questions that would show us that. Um, all right, let's look at. So I'm probably stepping it down a bit for you guys here. All right. So next step. Okay. None like this here. All right. Let me just be improvising, and let's use a new slide. And so the question is now. The question for you guys is that, and all right, let's see it. Yeah. All right. So basically, all right. And and then for this one now. All right. So look at these two questions now, guys. Do you think you can manage these questions, Tiffany?
Sir,
All right.
sir, may I go try?
Okay. All right, let me know when you finish. Um, Kemar,
Yes, sir.
you able to work the question?
Repeat that, sir.
You able to work the question?
I'm trying it, sir.
Sir,
Yes, Caris.
sir, I'm having network difficulty. Every minute it's a jump off and a jump on back.
Sorry about that, Caris. So well, can probably send the link.
Sir,
Yes, Caris.
when you finish, so you're going to send this in the group.
But I can't send it in the group because I don't have a phone.
So you could send it to our email or our personal email.
Oh, well, yeah. All right, I'll give you the link. Yeah, I'll give you the link for it after class.
Okay,
Uh,
thank you.
all right. This is something. Probably just send this. Let me send it to you. Hey, Caris. Caris,
Yes, sir.
you see the message?
In the chat.
Yeah.
Yes, sir.
Okay.
Sir,
Yes, Tiffany.
continue, sir.
Continue. Where's the answer?
Sir, go. Sir, the question, sir. Sir, me do some, but this no look right.
Uh, what is it that you have? What is it you have for A?
Sir, for A, me get um 62.86.
All right, what you get for B?
Oh, me get um sir, me get 1,257.2.
Okay. All right. Fair enough. Kemar. Kemar,
Yes, sir.
what answer you get for A?
Sir, me never finish it.
Hmm. All right, Caris.
Yes, sir.
All right, you see in the screen?
Yes, sir.
You know what to do the first question?
Sir, I guess so. Sir, me just write them down because my internet did gone.
Okay.
Sir, give me 1 minute, please.
All right.
Sir, me come back.
Okay. All right. So, all right. This is Let me see what's happening here. Um, First of all, this is grade 10 work. That's the first thing. And secondly, um, let's just work through what you should get. All right. Object of mass 20 kilogram travels a distance of 10 meters in 10 seconds. Calculate the velocity of the object. All right. All right. Velocity, first of all, let me even do one better here. We're not actually separate these two questions. Let's come here and select this. Let's just group them together and put it on a screen by itself because here is that's a new slide. I'm going to put it here and the velocity of the object. Well, first of all, so velocity in this case, we're going to treat as speed. And speed is equal to distance over time. All right. Now, the distance based on the question was 100 meters. The time was 10 seconds. Let's go back to the question because I don't know why persons overthinking. This is grade 10 work. All right. 100 meters in 10 seconds. This is distance. This is time. And all you simply do is put it in the formula here. Speed equal distance over time. 100 over 10 is 10. Simple as that. So the speed is 10. Everybody see that?
Yes, sir.
Yes, sir.
All right. Now for B, let's go back to that question. B asks for the momentum of the object. Again, let's group it together and put it on another page. All right. Put it on the same page. There's no space there. All right. And we'll put it down here. So part B says, what is the momentum of the object? All right. Always say we find the momentum again. What do we find
P
momentum?
equal M times V.
All right, good. So momentum is the same thing here as mass time velocity, or as you say a while ago. You could say P is equal to M times V. All right. Now, all they're going to do is get the mass. All right, the mass in this case is how much?
20.
And then the velocity here
Mm-hmm.
is going to be 10. And when you multiply these two numbers together, you're going to end up with what number?
200.
Right. That's it. As simple as that. Do you guys have any questions?
No, sir.
No, sir.
All right. All right. So that is using the mass times velocity here. Now, all right. Let's look at it a different way now. All right. No. All right. So a force let's write this down. Yeah, sorry. All right. So a force of how much should I apply? About 500 newtons. So 12 seconds. All right. Calculate. Yeah, calculate the all right. So have a look at that one now. All right. Read this question carefully and tell me what two things you're given in the question.
Sir, then give it time.
Right.
Sir, on the force.
All right. Did you get a formula that has time and force in it?
Yes.
Mm. Tiffany, Kemar,
Sir, I can't recall, sir.
can recall. All right.
Sir,
Did you
what's
know
the
that?
question?
Did you get a did you get a formula with force and time?
No, I don't remember. I don't
Don't remember. All right. What if I told you that you did it before? What is this? What is this that you write off the board? You recall now?
Yes, sir.
All right. So one of the problems that you guys have is that you're not recalling, and I can't help that. That is not something you teach. Something you're born with. Anyway, let's go there. So this is the formula that is important. Change momentum over time equal force. So apply that formula and solve this question.
Sir, I will get 41.6.
All right, so you're going to get 41.6. All right, let's see what happens here. So it's gonna be, so how you get the 41.6? Why you don't know, Tiffany?
Sir, me divide the force.
All right, so hold on. So the first of all, you write the formula. When you solve the question, you write the formula, right? So
Yes, sir.
them ask if the change in momentum, you are given the force and you are given time. So change in momentum, right, over time is equal to force applied. And just write force then. That's the first thing you're supposed to write. So now, all right, Tiffany, what is it what is it you're trying to find?
Change in momentum.
Sir,
Okay. So you're
Sir,
yes.
at 6,000.
All right. So Kerry's got 6,000. All
Yes,
right, and
sir.
then Tiffany get 40. How much you say get?
41.6.
41.6. All right. Well, first thing, and that's why I tell students to write the formula first. But you guys interested in getting the answer more than how to get the marks. So that's going to make you fail the exam. Focus on the steps. Focus on getting the formula, writing the right formula. Right? Focus on underlining the words in the question, picking out the information, writing the correct formula. The answer will come automatically. Sometimes it might right, sometimes it might wrong, but you not get much marks for that. You get more marks for the steps. So change momentum is what you're finding. We have to rearrange this formula now All right, if we arrange the formula now, remember I said time is over here. We multiply both sides. So we end up with something like this. If you did it correctly, all right, it should be change in momentum is equal to force. Let's write it properly. Force times time. Everybody see that?
Yes,
Yes, sir.
sir.
The force is 500 newtons. The time for which that force acted was 12 seconds. And if you multiply these two numbers, what we end up with?
6,000.
Yeah, 12 times 0 is 0, 12 times 0 is 0, 12 times 5 is 60. And you end up with 60. So you end up with 6,000 Newton seconds. That's it. All right. So again, let me just emphasize to you that this is grade 10 material. And these things are not taught at Cape, but because you guys are behind, this has to be done. So I'm doing it only for your benefit. Right? Again, that will sacrifice what we should be doing. But again, in my opinion, it's better that you understand a little than you get a whole lot and you don't understand it. None of it. So I guess that's how it is. All right, guys. So that's it. Thanks for coming out today. Um, you know, just write off this and then tomorrow we'll pick up. We're going to module 3 tomorrow. We're going to look at continue looking at temperature and thermodynamics. All right. So enjoy the rest of your day. And if you don't have any questions, I'll see you guys tomorrow.
Bye, sir.
Yeah, bye, Tiffany.